Okay, we're getting ready to put our strut back in here. We've had it in here once, holding it between centers, and we want to cradle the strut, a hub, with the piece of channel. It fits in there nice, and it gives us a nice flat bottom, and we'll be able to clamp it in here. We've cut two 1/2 by 3 inch flat bars, drilled holes in the locations we wanted. T-nut slots, you can see here's a slot here, so there's 3 T-nut slots in this engine carriage, and it's typical of the older style engine lathes. So we welded these welds here in the other room there, and now we're going to set this in place here, and we're going to be welding it to the bases here. But we got to set this in place. We're going to put the strut back in here, and we're going to get this set in exactly where it is, and then I'm going to show you the do's and don'ts about welding in a lathe. Got a nice snug fit, I like that. I want to position a pre-planned destination there. Alright, that looks good. Okay, I'm set up now to go ahead and weld my 2 pieces of the jig together. General rule, whether it be lathe, mill, drill press, whatever you're in, when you're welding on an item in a machine, you want to ground the item that you're welding. Do not just clamp this onto the lathe bed and expect not to have the possibility of damages for wherever that current has to go through to get to the part that you're actually igniting with your welding tool. If this was something that I was welding on that's in the lathe that I was turning, like this part right here, and I wanted to do a little touch up on it or whatever, of course, if you're spinning things in the lathe, sometimes you can't grab it with the welding clamp. Then, if it's, and only if, that part is chucked by the chuck, you would be able to take and, if you're strong enough, put your clamp on hard like that. Then you know that you're not going to be arcing out through the spindle bearings. On a lathe, the spindle bearings, mills, it has spindle bearings. These are the kind of bearings that are really high-tech bearings that you need to avoid damaging. You could be into thousands of dollars of repair if you wipe out a set of bearings. That's the do's and don'ts about welding. Alright, so let's get going. Also, any welding that you're doing, you want to protect the ways on the lathe. There are surfaces on the mills and drill presses. And you want to make sure that you're protecting those areas from arc and also from splatter. Most of the time, cast iron, the splatter will come off, but it will give you a little blend there. And you have to make sure that it's all smooth. Alright. Now also, if you got one of those hands like Gene Wilder, Blazing Saddles, grab your rod with your other hand, guide it into where it needs to be, and then initiate your arc, and then you can weld from there without accidentally stabbing it onto a part or another part of the machine that you don't really want to damage. take your rod out. You got to go over there and weld on that side, take your rod out. You could accidentally put it over there while you're walking around the end. Your rod could flip around and then arc off of another piece of equipment there. Now I have access to get the inside of that leg and the outside of this leg, which is fine with me. I think I'm going to do that. Okay, the way this jig is going to hold this is by Bessie clamps, which are probably the greatest invention, I think, as far as the C-clamp going. And I got a nice flat surface there, and these are cutoffs that I use in another jig to grab a lot of struts. Same type of application, different machine. Alright. Now, okay. Now we can pull out our center. And we're holding the strut for a line bore. Now we can start figuring out our bar, get our bar set up. We're going to hold our bar in the chuck, and we're going to change this out to a regular center. We'll be supporting the boring bar over there, and then we'll spin the tool bit and then adjust the tool bit for the diameter of the bore until we get it to size. Now, I've already slid this inside the bar, brought the tool bit out, touched it, took a light sweep, and I was just barely kissing over here. Now I'm going to set it up to take, like a 10,000ths cut, and we're going to run it through so that we can make sure that we're going to be running center. We'll take some measurements, make sure that the wall thickness is equal and that our setup is truly in line, and go from there. What I usually do is take a mag base with a V bottom, put it right to the shaft, and go ahead and get your stem of your dial indicator to touch the end of the tool bit. You can come off the butt end of that, but this is down inside, and getting your indicator set up in there, just not as visual as this is here. And we're just going to take 10 per side, so I'm going to come straight out 10. And there's 10 there. You can actually see it move a little bit when you do your tightening and loosening. Some adjustments on boring bars like this, I could tap this side out, put a real fine threaded adjustment screw in here, probably Allen set, and then I can progress it in. But we're gonna do it the old-fashioned way, and that is setting your tool bit like that and work our way out to size. We are gonna answer the phone. Okay, we're measuring up the bore here because we're getting real close, and these here are a pair of inside spring calipers. But what I use on a boring job where I got a bar in the way is a nice set of offset inside spring calipers. And I reach in here. Basically, you're putting this on one side of the bore and you're moving the ball of this in the largest diameter, which is the diameter of the bore. But you got to get in there and get that feel of what that dimension is, and that's what I'm doing here. Alright, and then after that, you hold it in your hand. I like to hold them like this because I cradle the anvil part of the mic there. .610 and 625, the 5/8 diameter is the finished bore. So we're going to take 5. This is why I like to really set up this mag base. I can lift up the plunger and I can swing this because I've already set the indicator so it's straight in line with the tool bit, and I can roll it one way or the other up and down the bar till I know I'm in line, and then I bring it down where I'm sitting right on that point. Alright, set a good 0 there. Now I'm just reaching in and I'm controlling the in and out of the bit with this hand and loosening the tool bit here. And we're pulling it out. 5. We're watching and making sure that it stays on 5 when you tighten it down. Alright, we got that. Now theoretically this will be our second to last cut. We're taking a 5. It's been constantly taking 10 per side at measurable increments, always on the mark. Now we're going to take 5. If it comes out to where it's only 5 left, then we'll take the 2.5, take our cut. If it comes a little bit more or leaves us a little less than the 5, then we will take a spring cut and we'll see what that bore is, and then make a decision on how much we're going to feed it in. Tool bit pressure, this was sharp when we started. It's not as sharp, but it's still doing a real nice cut job, and we don't want to mess up our reference where we're at right now. Okay, we're right there between 619 and 620. Both sides feel the same. We're going to go ahead and take 2.5 thousandths and go for our finished cut right now. Okay, we went ahead and slid back our tailstock here and get a good look at the bore. I'm happy with that. And we wanted to check the fit of this before we break it down and chamfer the edges here. And I can get it just to start in by hand. This is going to be an excellent fit for a cutlass bearing. Alright, now we're going to go ahead and we're going to break this inside leading edge, both ends, just so it's not a real sharp edge.